SpaceClaim is a 3D direct modeling solution that will optimize your additive manufacturing or rapid prototyping engineering process. In this demonstration, I will show you how you can take advantage of SpaceClaim's unique direct modeling approach to quickly and easily use a slice and dice method to split your geometry into smaller solids that will fit within your build envelope, and also seamlessly create lap joints to fit these solids back together after printing. I'll also show you how SpaceClaim's simple UI allows you to repair and edit geometry that you receive, regardless of the original CAD system or file type. SpaceClaim can import 3D and 2D geometry from any file type you're used to receiving. You can see from this drop-down that we read in ASYS, Parasolid, and IGES files, as well as direct import of parts from SolidWorks, ProEngineer, or CATIA. In this case, I will import a step file, and as you might be used to with imported geometry, this part comes in as dirty geometry consisting of multiple detached surfaces. This is no worry when working with SpaceClaim, since we have an entire suite of repair tools to allow us to stitch these surfaces together, as well as detect and immediately repair any gaps or missing faces. Once we've repaired the geometry and are left with one solid, we can use SpaceClaim's simple and intuitive user interface of the pull, move, fill, and combine tools to edit this geometry. Using pull on faces and edges to adjust the length of a wall, the radius of a fillet, or the draft about a face. Move to translate or rotate any geometry. Fill to remove rounds, protrusions, depressions, or faces from the geometry. And combine to cut and merge intersecting geometry, such as this plane, which I can easily create on the fly. Because SpaceClaim is a direct modeler, making edits directly on the geometry, we can employ a unique slice and dice approach to create multiple solids that will fit within our 3D printer's build envelope, and easily add lap joints for reassembly. Instead of spending time sketching new features, we can reuse the existing geometry on screen by pulling on the existing boundary edges to copy them into the part and pulling the resulting face out into a protrusion. Then by moving the solids back together, we can use combine to cut the complementary depression into the other solid. Or pull on the protrusion for the lap joint to create a parametric tolerance. Once we have our resulting solids, we can quickly create an assembly structure or isolate each solid to save them individually as SpaceClaim documents, or export them to any file type including Parasolid, ASYS, IGES, STEP, or even bitmap or JPEG files, or in this case as an STL file to be sent to our 3D printer. I hope you've seen how SpaceClaim can be used to save you time and money by streamlining your additive manufacturing workflow.